Good morning, good afternoon, and good evening, everyone, based on the time zones you all are coming from. So, before we get started, can you all please give me a quick information? If you all can see my screen and hear me loud and clear as well. Perfect. Thank you for the confirmation, everyone. So, without further ado, let me just start with the introduction to our Edureka Masterclass with you all. So, this Edureka Masterclasses was started back in 2019, and since then, we have been closing into more than 33,000 members so far. And in these masterclasses, we conduct different webinars and live events on different topics, including blockchain, IoT, artificial intelligence, machine learning, and multiple big data and front-end development technologies. And the best part about these webinars are they are absolutely free of cost, so there are no charges involved here. And these are a really great platform for getting started on how exactly we can make use of our different technologies and helping us in getting into the industry vertical that we want. So to be a part of this group, we can simply click on this option which says join this group, and then we will be notified with the entire schedule that we have planned for the month. So first of all, we are going to discuss on Kubernetes for container orchestration, where we are going to discuss on the need of Kubernetes, what exactly it is and what is not, and how does Kubernetes work. And then if time allows, then we are going to see a small hands-on on top of Kubernetes as well. All right, so Kubernetes is a part of the container orchestration tool. When we say container orchestration tool, it simply means that it allows us to manage the containers that we had deployed specifically on Docker environment. So Kubernetes is basically a platform that eliminates the manual process involved in deploying containerized applications. And before, as we know, okay, before the containers they came into existence, the developers and the testers always had a tiff between them. So this usually happens because what worked on the development side would not work on the testing side. So both of them existed in the different environments. Now to avoid such scenarios, these platforms were introduced so that the developers and testers were on the same page itself. And handling a large number of containers altogether was also a problem. Sometimes while running containers on the product side, few issues were raised, which were not present at the development stage. And this kind of scenario introduced the container orchestration system here. So both Linux containers and Docker containers isolate their applications from the host, and there we get a faster and we can say much efficient performance. But they are not easily scalable. That's the main drawback that we have in Kubernetes, right? So we also have different platform now. Kubernetes is not the only platform, but again, if you want to scale them up, again, that is something not possible in here. And that's why we have Kubernetes as a platform available that allows us to scale up the servers whenever we want. So, and plus, again, setting up the services manually and to overcome the challenges faced here, again, it was, we can say, a big task. And that's where the container orchestration engines comes into the picture. So this engine let us organize the multiple containers and in such a way that all the underlying machines are launched and containers are healthy and distributed in a clustered environment. So in today's world, there are mainly two different type of engines that we have. So we have Kubernetes and then we have other one as Docker Swarm. So Kubernetes is basically a large scale, Kubernetes is suitable for large scale infrastructure, whereas Docker Swarm is suitable for small scale infrastructure as well. That is how they are structured. And now the main problems that we had earlier was containers could not communicate with each other in case they want to. And then the containers, they had to be deployed appropriately and containers had to be managed carefully as well. And the auto scaling was not possible. We had to manually scale them up. And even when we have a big cluster, then distribution of traffic was always challenging. So that's where these all solutions were introduced, like we have Kubernetes. So they both are the leader in the container orchestration tool. And as we discussed, Swarm is useful for small scale infrastructure, whereas Kubernetes is useful for large scale infrastructure here. And Kubernetes is basically written on Golang itself. So it's like an open source system that handles the work of scheduling containers onto a compute cluster and manages the workloads to ensure they run as the user intends. And being the Google's brainchild, it offers excellent community and works brilliantly with all cloud providers to become a multi-container management solution. And right now it is used as a standard for managing multiple containers. And this was deployed with, or you can say by Google as a part of their GCP, as in Google Cloud Product Solutions. And since then, it has been one of the main platforms being used. And it is written on top of Golang. It can group n number of containers into one logical unit for managing and deploying them easily as and when required. So there are multiple features of Kubernetes. So again, it simply allows us to have the automatic scheduling. We can have it has the self-healing capabilities. It has the automated rollouts and rollback. Horizontal scaling and load balancing is also available here. So in terms of automated scaling or just scheduling, so Kubernetes provides advanced scheduler to launch container on cluster nodes based on their resource requirements and other constraints while not sacrificing availability. Then we have self-healing capabilities. So Kubernetes allows to replaces and reschedule containers with when node when nodes simply die. And it also kills containers that don't respond to user-defined health checks and doesn't advertise them to clients until they are ready to serve. And then we have automated rollouts and rollbacks. So Kubernetes rolls out changes to the application or its configuration while monitoring application health to ensure it doesn't kill all our instances at the same time. And if something goes wrong with Kubernetes, we can always roll back the change as well. And horizontal scaling, and if we talk about horizontal scaling and load balancing, so Kubernetes can scale up and scale down the application as per the requirement with a simple command and using a UI, or we can say an automatically based CPU usage as well. Now, in terms of Kubernetes architecture, we have, again, it is divided into master nodes and the slave nodes as well, where master can simply manage the entire cluster and can simply distribute the job among different worker needs, we can say nodes as well. So what Kubernetes is not, so again, it is not meant to be compared with Docker because Kubernetes simply allows us to manage the Docker containers. So there's no point of even thinking about comparing Docker with Kubernetes. Docker is a tool for containerization. We don't create containers by using Kubernetes. We simply allow Kubernetes to manage containers deployed on top of Docker, right? And then it is up for applications with simple architecture. If we have a simple architecture, then we don't bother about even thinking about Kubernetes. Then we can use a small scale infrastructure management tool like we have Swarm offered by Docker itself. And then it is for containerizing applications. That is not the case. Kubernetes is the orchestration tool. It is not a containerization tool like Docker. And that's why it can be used for work for managing containers, but not to create them. We don't use it for creating the containers. That's how it is structured. And then what Kubernetes actually is, it is the best solution for scaling up containers. It is backed by a huge community, and it is like a container orchestration platform that we have. And then it is robust and reliable as well as compared to its counterparts, especially when it comes down to large scale infrastructure. Now, though it is not easy to install, it is one of the most complicated systems to install in any platform. But again, the complexities, they always surpass the advantage that we have in terms of managing large scale infrastructure, all by using Kubernetes. And if we compare Kubernetes with Docker Swarm, then Kubernetes is basically complicated. Obviously, it is complicated and time consuming, the same thing that we had discussed right now. But again, it is useful for large scale infrastructure here. And again, the installation process of Docker Swarm is really easy and it is fast as well. We have the GUI available for Kubernetes, which is not available by default for Docker Swarm. GUI as in, again, we have a complete graphical dashboard through which we can see the status of all the containers that we may have deployed. And now if any of the instance is not healthy, they need more attention, then we can get a better insight by using GUI, which is not going to be possible by using any CLI statements here, right? And then in terms of scalability, scaling is low as compared to other platforms. Scaling is always low as compared to Swarm. And scaling is again faster than Kubernetes. Obviously, it is logical because it is used for small scale deployment. So obviously scaling is going to be much faster here. And then in terms of load balancing, so load balancing requires manual service configuration, whereas it has the inbuilt load balancing technique available for small scale cluster. And then for updates and rollbacks, so again, the process has to be scheduled. So again, there is a process scheduling service to maintain services while we are updating. So that, okay, so suppose if you have 100 containers, again, those containers which are currently getting updated, they are not going to be part of load distribution, whereas all the other components are going to be part. So they can take the additional load. And then here only shared with, in terms of data volumes, they are shared with the containers in the same pod. Pod is like collection of containers. And here we can share the volume with any other container because there is no concept of any pods here in Swarm. Whereas in terms of logging and monitoring, we have the inbuilt logging and monitoring tools available. Whereas in Docker Swarm, we have third-party logging and monitoring tools currently available here. That's how it simply works. All right. Now let's talk about the Kubernetes architecture, how exactly this is defined. As we discussed, it is basically based on two different components here, master and the worker or slave nodes. We have master and the worker or slave nodes here. So master node simply is responsible for management of Kubernetes cluster, and it is mainly the entry point for all administrative tasks. And there can be more than one master node in the cluster to check for the fault tolerance. Whereas if we talk about the jobs, again here are the main responsibilities of the Kubernetes cluster master. So here we are going to have the API server. So API server is the entry point for all the REST commands used to control the cluster. And then we also have a controller manager, which is like a daemon that regulates the Kubernetes cluster and manages different non-terminating control logs, logis loops. And then we have scheduler. So scheduler schedules the task to slave nodes, and it controls, or you can say it stores the resources, or you can say resource usage information for each slave node. And then we have the something called as etcd. So etcd is a simple, distributed, and consistent key value store. It is mainly used for shared configuration and service discovery. And then we have all these slave nodes, or we can refer them as worker nodes. So worker node contains all the necessary services to manage the networking between the containers, and they allow us to communicate with the other master node and assign the resources to the scheduled containers altogether. So worker node also has different components that we have. So it also has, now as you can see here, this is the same component that we discussed. We have the node, the Docker container, and then we have pods. So pods are simply the collection of different containers out there. And then we have, okay, before that, we have the slave nodes. So slave nodes, they contain multiple components, like we had Docker container, which contains the, on, again, which simply runs on each of the worker nodes, and then it simply runs the configured pods as well. And then we have kubelet. So kubelet gets the configuration of a pod from the API server and ensures that the described containers are up and running. And then we have kubeproxy. So kubeproxy acts like as a network proxy and as a load balancer for service on a single worker node. And then we have pods. Pods, as we discussed, it's like a collection of one or more than one containers. That's how it is simply structured here. All right, so now let's see a small hands-on on how exactly we can set up the Kubernetes cluster as a part of our discussion. So for that, for having a good discussion here, we are going to refer to the cloud itself. So here we can simply go ahead and deploy one cluster that we can work on. So we can set up Kubernetes environment locally, or we can use any of the cloud platforms to get started. So currently we are going to make use of our AWS cloud. So here we can click on launch instance, and under launch instance, we can specify node versus pod, please. Node is the individual container. We can say that Educa guest, and pod is like a collection of multiple nodes. Pods are like a collection of multiple containers. That's what we mean. All right. So here we are going to work on this on these different stacks here. So here we can define it. Now basically here we are going to deploy the entire stack by using the AWS environment. So here we are going to search for Kubernetes. Let's define the Kubernetes environment by using Bitnami itself as a part of the cloud platform. Let's say we deploy this on T2 Medium, add storage, add tags. So Kubernetes is going to answer on this given port here. So we have to make sure we do define the access to these ports, and that too, if we are going to make it public, then we can answer this from anywhere, so that they will be able to access the dashboard from anywhere. And once we are done, we can go ahead and click on launch. Let's choose a keeper that we may have the access to. So usually it is going to take a bit of time for this one to be deployed. All right, so here we can click on view instance. Let's filter this based on the state itself. For the running state, let's say we can name it as Kubernetes. Now, in order to get connected, we can simply use this IP that we already have, and we can use the internal SSH-based client as well. So we already have defined, we have changed the modification of the key file that we have downloaded that we are going to make use of. And this is the IP address for the instance that we have deployed. So we are going to get connected to this instance by using the IP itself. Okay, let's just cross check if we have given the access to SSH for this one or not. So as you can see, now we have connected to the instance by using a simple SSH based client. And again, if you want to use any other client, for example, if you're running Windows or let's say a Windows platform, then you can use, let's say, MobileStorm or PuTTY in order to get connected, which is one of the most popular platforms for SSH. And we can configure Kubernetes on any specific platform, or if you want, we can simply start by downloading all the packages and configuring them as and when required. So sometimes it usually takes a while for the entire instance to be configured. All right. So if you want to see how we can deploy this locally, so we can simply go ahead and get connected to any dummy Ubuntu instance as well. So we can go ahead and launch another instance. So I can show you the process, how exactly it works manually. So if you're looking to install the system manually, then we can give the custom access to all TCP protocols for now from anywhere. Let's launch it by using the same key pair. So here we can define a simple Ubuntu instance, and if you are looking to work on Ubuntu, so here we can run the same commands here. So here we have to verify the key file as what we had defined under downloads, and then we have to specify the key file, which is by the name of may18.pm, and then we have to use SSHI. Then same way we have to find the location or the same key file that we have downloaded. So under downloads, we have may18.pm, and here we have the username that we have defined. And then this is going to be based on the IP address, which you can fetch here. Still, we are waiting for this one to be deployed, Manikant. That's why it seems like it is frozen. Okay, now it is available. So now we would be able to get connected. We can find the fingerprint to be yes. All right. So once we have configured that, so first of all, we can simply go ahead and run the upgrade here. So here we have apt-get update so that we can resync all the services that we have. And first of all, we also have to install and set up Docker as well. So again, they all can be fetched from the same repository that we already have the access to. We can use sudo apt-get install docker.io. And once we have configured that, then we are going to specify the Docker version as well. Then we can define Docker just to check if Docker has been enabled or not. And then we have to enable Docker as well as a part of systemctl. And then we can simply enable Docker as a service. So Docker now has been enabled. And now just to cross check, we can define systemctl, and here we can define status for Docker if it is up and running. It's not Docker, it's Docker. So as you can see that Docker service is currently up and running, so that's good. So now we can simply come out of it, and then we can simply go ahead and define sudo system in case we are going to, if it is not up and running, then we can simply run the Docker as well as and when required. Then we have to add Kubernetes signup key as well. So we have to define the signup key for Kubernetes. So here we have to simply add the Kubernetes silent key, because before we configure the installation, this requires to be done. So again, as you can see, it is okay. And then we have to use sudo apt get install, and then here we have to install kubeadmin. So here we define sudo apt get is the default package here, and then we can define install, and here we can define kubeadmin by using kubelet, and we also want to install kubectl as well. So these all packages are required for us to work with Kubernetes. So it usually takes a bit of time here, and that's how it is configured. Once we have installed these libraries here, then we can simply have we only have to initialize the Kubernetes on the master node, and then if in case you want to add pods, you can configure pods as well. So as it's been almost time now, so let's do one thing. Let's wrap it up for today. Thank you so much for joining, guys, and have a great day ahead. Take care. Bye-bye.